let's see how you can use Blender for making a creature like an octopus that is completely driven by physics simulations, which is an amazing news because the octopus will interact with the environment, will destroy stuff eventually. You just have to decide where the octopus is gonna walk, and Blender is gonna figure out everything automatically for you. It's a pretty experimental workflow that I figured out in these days. It's nothing like rigging or cloth or soft body, nothing like that. It's a new experimental workflow that I'm sharing with you right now. Before starting, the sponsor of this video is absolutely nobody. So consider joining my Patreon. I leave you the link in the description. In my Patreon, you can basically learn all the things that I do about physics simulations in Blender, visual effects, CGI combining real footage, mostly stuff like that in Blender, but more frequently. And at the same time, you are supporting this channel. Let's go! We start by blocking out the very basic rough shape of the creature that you have in mind. Just one cube, using a subdivision modifier level of 2. Using more cubes, you just have to barely represent the basic shape. We're gonna refine that later. Once you are happy, you can press F3 and search for the function convert to mesh, which is basically gonna apply all the modifiers. Just select one of these objects, holding shift, select also all the others, and you can go in the menu object and join. Now all of this is one single object. This way we can take advantage of the remesh modifier to basically reshape in a better way the entire creator, tweaking the remesh a little bit until we are happy. And of course we're gonna have to refine it. Constantly keep under observation the amount of geometry that you are generating. The remesh might generate some unwanted surprises like this, and that's why I also use some other modifiers like the solidify, the smooth modifier, in which I increase the repeat option a lot, until basically I get the shape that I imagine. And for the additional final refinements and little details, we can jump into the sculpt mode, in which your best friends are gonna be the inflate tool, the smooth tool, and the grab tool. Look, I know nothing about sculpting and modeling, but this is very easy. And by the way, there are a lot of tutorials about modeling more in details an octopus or tentacles. I recommend watching especially this tutorial here on YouTube from this guy that has made an amazing job in just 1 minute for making proper tentacles. Speaking which, just for you to know, an octopus doesn't have tentacles, has arms. Kinda disappointing, but it is what it is. By the way, once you are done, you have to check the amount of vertices that you are having for a decent performance in the viewport. Now, if you select this object and press N, you can check how much big it's gonna be. So under Item, Dimensions, I want this octopus to be 5 meters in the biggest dimension that you see here. The scale is very important when it comes to physics simulations. Now I'm gonna press Ctrl A, apply scale and rotation. And if you have some modifiers, just ensure that you have applied all of them, by the way. So we can start finally the physics simulation part, for which I'm gonna use RBD Lab add-on for Blender. It's not free, you can purchase it on Blender Market unfortunately, but is everything that Blender was missing for physics simulations. So I was thinking we can use the metal soft deformation for creature deformation. Why not? Let's do it. I'm gonna select this octopus here. I'm gonna go under prepare and proxy. We basically generate a low poly, very simple geometry version of this octopus. We're gonna fracture that simple version. We're gonna apply all the dynamics of the physics with rigid bodies to this simple version. And then we're gonna attach the original mesh, which is very high poly, to those rigid bodies. So, with this object selected, I'm gonna go under prepare, proxy. I'm gonna choose first a remesh. And basically we are remeshing, which means that we are getting rid of all those little unnecessary details. And basically we can tweak this voxel size until it is at the same time low poly and good looking, more or less. Smooth shading, why not? As I said before, the remesh generates some surprises like this, and that's why I also use the solidify. So from RBD Lab add-on, add solidify, but I want to put this solidify in the right order. So if you take it from here and move it before the remesh, it should actually help the remesh to work better. We have to increase the thickness a little bit here in the solidify, and boom. You can see that it's filling those ugly gaps in a better way, basically. We can adjust these settings of the thickness and the remesh until we are happy. We can keep the amount of vertices under control. 3000 is more or less what I need. This is a simple version of my octopus, doesn't have unnecessary details or weird geometries. The shape of the proxy should be as much smooth as possible, alright? So, add modifier and search for smooth. I'm gonna increase the repeat option a lot. until basically I get rid of those ugly spikes that can potentially interrupt the workflow of RbdLab later. So I'm gonna stay with like 13, and you can see that it's shrinking the shape of this octopus a little bit, so we can by consequence increase the thickness of the solidify. You know, you just go on tweaking these settings together until it's completely smooth. Let's try. I'm gonna apply all of this from RbdLab. I scroll down and I click on accept. Boom, we have the proxy shape. Now the last thing that I want to do, I want to have thickness just in the head, because right now it's just like this if you look in transparency mode. And the thing is, for allowing a little bit more of soft movements in the head, like wiggly, you know, up and down bounces, I want to add thickness, but I'm gonna do it manually because, you know, the solidify modifier is gonna add thickness in the entire mesh. Instead, I want thickness only in the internal part of the head. So, easiest way to do that is by simply creating manually a sphere, more or less respecting the internal part of this. And by the way, we can refine it more in edit mode if we use the proportional editing. You can see here this button. So if I take it, for example, from this vertex and then I press G, if I scroll up or down the mouse wheel, it doesn't have to pop out outside like this. This is not good with the proportional editing, and you push it inside a little bit like that. And yeah, so the next thing I want to do is to basically, well, we can first join this together with the proxy. So if you select first this sphere and then holding shift, you select also the proxy. Pay attention, not the original octopus, which right now is invisible, but the proxy. In this order, so first the sphere and then the proxy. Then with these two objects selected in this order, I'm gonna go under object and join. And now this is a single object like that with thickness in the head. We have to do a last thing, by the way. I'm gonna show you without transparency. I'm gonna go here and activate the face orientation. We have to adjust the orientation of the internal faces, basically. So first of all, let's enlarge the focal length of the view. Under view, focal length, I'm gonna drop this down to something very wide, like 12 millimeters, because I want to enter inside the skull. And you can see that inside the skull is red. Instead, I want this sphere, this internal sphere of the skull, to be blue. We have to invert the normals, basically. What I mean is, just go in edit mode and activate the transparency, maybe. So first of all, click outside to deselect eventual selections and put the mouse something around here and press L. It should, yeah, there we go. You can see that I was able to select the internal island, we can say, in just one click. Now let's go inside like this. We can turn off the transparency so we can see the faces orientation. In faces mode, so this button, with the mouse here, I'm gonna press Shift N, and in the pop-up menu here, I'm gonna expand it, I'm gonna click inside. Cool, I have just inverted the normals of these faces. So basically it should look like this. The internal of the head should be blue, the thickness inside should be red, and outside should be completely blue like that. By doing this, we basically are gonna avoid any issue with the fracturing of this object later. Alright, we can go in object mode, and alright, now we're gonna fracture the proxy, not the original because it's too complex, but the proxy. So with the proxy selected under fracture, I'm gonna go under scatter, add a standard scatter. I'm gonna increase the number of points in the density a lot, like until it's full, basically, more or less like that. And I'm gonna click on accept. And finally here we can decide how many chunks we are gonna have. I'm gonna choose 250. Don't exaggerate with that, of course, because the more chunks you have and the slower Blender is gonna be during the simulations. Scroll down and click on fracture. This is gonna take just a few seconds because our geometry is simple. And here we go. And just to check, I'm gonna simply select all of this like that. I'm gonna click on select bed chunks, and then I'm gonna click on auto fix. This will fix some problematic parts that might happen. Speaking which, we can check inside the skull if we have some errors in the fracturing, basically. I say that this fracturing is going pretty well, so we can proceed. So, apply fracture now. And finally we have the fractured version of this proxy. I'm gonna move to the physics panel here, and I'm already gonna go under rigid body dynamics, RBD. First of all my favorite settings for an octopus scene are gonna be this. Rigid body world, sub-steps per frame, I'm gonna increase this to 10, just to have more accurate collisions basically, and more interesting dynamics with the tentacles, actually with the arms. Then I'm gonna scroll down and ensure that this option is active, which is gonna make some cleaning of the geometry before making the simulation. Activate Metal Soft, and I'm gonna set a mass of 0.1, which means that all of these chunks are gonna have a mass of 0.1, which for metal deformations is kinda necessary. I'm gonna scroll down. For both this damp, translation and rotation, I'm gonna set them on 0.01, which basically will allow more rotation and movement to the rigid bodies. I'm gonna scroll down and simply click on Add Rigid Bodies. Easy like that. Now if I play the animation, we should see the rigid bodies falling down like that. If they explode at this point, you're gonna have to go back and remake the fracture with a little bit more chunks. Usually fixes the problem. Or you're gonna have to clean up the geometry a little bit better. By the way, now we can move here, ground. I'm gonna add ground, increasing the friction for the rigid bodies, which is this one here, to the maximum. And I'm gonna make it invisible by clicking here. Cool. Now the rigid bodies are just falling down and bouncing on the floor like that. But I want them to be connected, and that's why constraints is what I'm looking for. Yeah, I'm gonna use all the default settings. Soft constraints is very important. Iterations, I'm gonna activate this and set this on 50, which for the soft constraints is basically helping to have more stable deformations, basically. I'm gonna go down and simply click on Create Constraint Group. And now you can see that we have moved from here to here. There's this constraint group, which basically means that if I play the animation, we should see the rigid bodies connected each other a little bit better than before, like that. It's still looking not that good, but we're gonna tweak some settings now. You know what? Before tweaking the settings for the constraints, I want to connect my octopus. So I'm gonna go under Metal Soft. I'm gonna click under Other Original, and we should choose our original mesh of the octopus from this drop-down menu here, but it's not present here. There's just the proxy, because we have to find it from here. So let's expand this collection here. Here is the original octopus, and we're gonna have to move this in this collection here, RBD Lab Originals. So take it from here, grab it, and move it in the originals collection, like this. Whoop! And by doing this, we can finally find the original octopus from here. And look at that. There is the proxy, and now there is also the original. So select the original octopus, and finally we can click on Create a Mesh Deform, which is gonna attach the original mesh to the rigid bodies. And look at that. Now, in any moment, using this button, you can switch from the rigid bodies visualization or the original mesh visualization. Let's see, if I play the animation, it's starting to take some life. Now we can tweak the constraint settings because it's just melting down like an ice cream. I don't like it. So, constraint settings. We're gonna put some limits in these constraints so that they don't go this far. Expand all of these settings here. I'm gonna activate all of this, activate all of this. Distance allowed. I'm gonna decrease this a lot, like 0.02. Let's try. And I actually suggest you to activate disable collisions, which actually helps the performance of Blender significantly. So I'm gonna click on Update. This is very important. When you change some settings for some functions of RBD Lab, you have to remember to click on Update down here. So if I play the animation right now, it looks like this. It's not bad, it's not bad. It's starting to become alive. Now, the first thing I notice is that the shape is becoming a little bit weird with all these kind of weird wrinkles. So what I like to do is to go here with this mesh selected, modifier, and I'm simply searching for the smooth modifier, this one here, ensuring that this is the last one of the list. And if we increase the repeat option a few times, it should help to, yeah, look at that, it's becoming smoother. So let's actually not exaggerate with this. I'm gonna decrease the repeat option a few times until I preserve basically my amazing details like that. Yeah, I say that this is alright and we can proceed. Actually, the last two adjustments that I want to do in the constraint settings, I want to allow a wider angle for the deformation, 90 degrees, and also under spring angle, I'm gonna decrease the damping a little bit just to 0.99. This has a huge influence in the dynamics of the arms. I'm gonna go down and click on Update. By doing this, basically, the deformation of the arms are not gonna just deform, but they are also gonna wiggle a little bit, like back and forth, which is more interesting for a creator that is supposed to look like he has life. Cool, let's proceed. And actually, there's a little issue. I can see this rigid body is deforming in a weird way like this. I'm probably gonna decrease the linear distance here to something like 0.01. should look a little bit better. Let's see. I'm gonna go down here and update. See any better? Yeah, it's looking much better than before. Now it's looking more like a single unique piece instead of showing all the fractures. Now, the thing is, these are just falling down, but I want this octopus to be driven by something. We can do this very easily. Let's go up here, Metal Soft, and let's reveal the rigid bodies. I'm gonna find one rigid bodies that stay. Let's see. Yeah, this is a good one. I'm gonna choose this one. You can see this is gonna drive the entire octopus. All the other rigid bodies are just gonna follow. So with this selected under physics, I'm gonna go under kinematics and I'm gonna click on set kinematic, but pay attention, not this button here, but this one, because this is gonna make the kinematic only in the selected part. So set kinematic. And you can see that it has changed color, like saying, hey, yes, I am a kinematic now. Let's see what happens if I play the animation. Now you can see that all the rigid bodies are falling down, following the rules of the physics, but the green one is staying there, is not moving. And you know why? Because if I select this, if I play the animation, and then, only then, I press G to move it. Look at that. I am driving the entire octopus. So, I'm gonna press ESC, because I want to leave that in place. And from now on, actually watch out, because I'm never gonna click Ctrl Z to undo something. Undoing things in Blender with physics simulation is gonna potentially crash Blender. So save a lot, save often. Now, the thing is, it's kind of annoying to try to select this object because it's, it's hidden. So let's do this. With this object selected, first of all, I'm gonna press Shift S and I'm gonna choose Cursor to Selected. And I'm gonna add an empty. I'm gonna choose a single arrow. In the option of the data here, I'm going to increase the size like that, just so that is very visible. I can put that above the octopus like this. Cool. Now, what I want to do is to select first this green rigid body, that is the kinematic one. Then, holding Shift, I select this empty here. I press Ctrl P, set parent to object. Which means that now, let's deselect everything. If I select only the empty, if you try to move it, you can see that the rigid body is following this empty. Now let's press ESC to leave it in place. Let's ensure that everything that you create is not inside the RbD Lab collections, so that we don't disturb the add-on. So with just this empty selected, I'm just gonna press M, move to another collection, basically like this one, and now this is here. Alright, now if you play the animation first, and then you press G to move this empty, you can see that the octopus is following along. Cool. I'm gonna press ESC to leave it in place, like that. And I'm going to interrupt the animation only after. Cool. And the thing is, we can simply animate this empty using keyframes, which is going to be very easy. Look at that. So on frame 1, I'm going to press I to leave it in place like that. I actually suggest you to don't change the starting position of the octopus. Let's leave the original backup as it is right now from the beginning. Then we're going to move something around frame, let's say 60. On frame 60, with only this empty selected, I'm gonna move this down like this until this rigid body is almost touching the ground like that. Let's see, like this. I'm gonna press I for inserting another keyframe, and let's see how it looks. Just pay attention to don't intersect the floor like that, because that's gonna, glitch the entire simulation. The tentacles are gonna go crazy. So let's see how it looks right now. If I play the animation, by the way, when you create the keyframes, you don't see the animation happening in real time. You see it only when you replay the animation, because the rigid bodies needs to be calculated frame after frame. So everything is following. Cool. Now we can proceed animating this empty like that. I would suggest you to don't make it moving too much fast. Alright, it's moving. I say that it is sitting pretty much well on the ground, but I don't necessarily like it. It's looking like just sliding right now, and that's why I am making now a good trick. Selecting this collection, and I'm gonna make a force. So Shift A, I'm gonna search force and turbulence. Turbulence is fantastic for giving the impression that this octopus is having its own life. So if we tweak the physics properties of this turbulence, look at that. I'm gonna increase the strength to 700, and the size, let's try a size of 2 for now, increasing the noise amount just to randomize as much as I can this turbulence. Wind factor, yeah, let's give it a little bit of wind factor like that. And if I play the animation right now, look at that. It's like dancing. It's looking like having life, basically. You can even animate the turbulence if you want, but the thing is, yes, now the octopus is moving, is alive. Well, this is probably definitely too strong. I'm gonna decrease the strength of this turbulence like to 600, let's try. Speaking of which, the size, you have to imagine like that, like waves in the air that are affecting the dynamics of these rigid bodies. And the size is basically the size of this wave. So if I decrease the size to, let's say, 0.5, the waves are gonna be like this, like much smaller, are more frequent, and that's why the tentacles are gonna be probably crazy, let's say. Yeah, you can see that you can actually visualize more or less the size of this turbulence. And just want something that basically looks like the octopus is walking rather than just sliding on the floor. Alright, I think that these settings are going good, but of course you are gonna need to tweak these settings until they work good for your scene. Every scene can be different. By the way, I want to see the final mesh. So MetalSoft, I'm gonna click on this button here, and finally I'm watching the real octopus moving, and look at that. And the thing is, you can add a lot of obstacles, and we're gonna have to adjust, of course, the keyframes for the movement. Right now it's just a little bit crazy, but yeah, it's up to you to tweak the settings of the turbulence until it's not that crazy. Well, I can already decrease this to 500 probably. By the way, I want to add some obstacles. So for example, always paying attention to don't put any objects in RbdLab collections. I'm gonna select this collection. I'm gonna add a sphere, mesh, a UV sphere. I'm gonna make it bigger. I'm gonna squeeze, intersecting the ground like that. Actually, let's visualize the ground. So under physics, ground, and I'm gonna click on hidden so we see the ground now. So every time you create a new obstacle, all the things that you have to do are press Ctrl A, apply the scale, right click, set origin to geometry, just in case. This is necessary for having correct collisions basically. We can also shade smooth. So in the physics properties of this sphere, I'm gonna say rigid body, passive, nothing more than that. And let's see how it behaves. It's a little bit slow because I probably exaggerated with the number of chunks. 250 is not a very good idea, and it is also not necessary. But oh, something else to pay attention. Yeah, we don't have to intersect the obstacles like that. We're gonna have to adjust the animation. And here we go. I have the first part of the animation. The first part of the animation, of course, is gonna be necessary to cut it in the final render because it's horrible, but it's necessary. Oh, look at that. So you are gonna have to make all the adjustments that you need for the keyframes. Yeah, the boring part is that you always have to replay the animation from the beginning. The first time you play, it's a bit slow, and the second time you replay it, it's faster, it's real time, because the physics calculations are made in the first playback, basically, every time you change some settings. I think this is fine. It's looking like, yeah, it's looking okay to me. The last tip that I want to give you is this. So basically, instead of having an octopus that just goes straight like that, I want this octopus to basically rotate like this, on left and right and left and right a little bit, because this is gonna help a lot to give the impression that he's alive. So to do that, we're gonna animate in an automatic way this empty. So look at that. I'm gonna make some space here in the timeline. I'm gonna change this to graph editor, and we're gonna expand these transformations here that has keyframes. I'm gonna find the Z Euler rotation, this one here. And basically with this selected, I'm gonna go here in the side. I'm gonna maximize full screen control space. If you don't see these side panels, you're gonna have to press N on the keyboard, N like known. And you can see here modifiers. And basically with this Z rotation selected, I'm gonna add a modifier that is gonna be a noise. We can scale it already like that, so that it's not that crazy. We can decrease the strength probably a little bit. Let's see how it goes. But it's very important that this noise must not happen in the beginning, because the physics has to be like the original, in the beginning at least. And that's why I'm gonna activate restrict frame range here. And basically, if you expand this, we can increase the end frame to the end of the timeline. But for the start frame, we can tweak this just so that it doesn't start in the very beginning, but something after. Let's say on frame 5, alright? So if I play the animation right now, we should see the octopus rotating a little bit on the left and the right constantly automatically for me. Let's see. I don't necessarily see any rotation. Let's see, strength, something like, I'm gonna exaggerate just to see what it does. Yeah, now you can definitely tell that it's rotating. Let's see, this strength is definitely too much. I'm gonna decrease the strength until basically it works like I would expect. Phase, I don't know what is phase. I'm just gonna tweak everything until is offset. I don't know. Let's try. Strength a little bit more. You have to make your own test in your scene until it works. Yep. By the way, yeah, this is also already pretty interesting, by the way. So let's press N under RBD Lab addon. I'm gonna go under bake. Well, before that, I was thinking that we can animate the turbulence. So turbulence, let's say that in the beginning, until frame like 20, we can say, I want a strength of 0, like 0. With the mouse here, I press I, and then progressively increasing the strength to 500. So on frame 40, I set a strength of 500. With the mouse here, I press I to insert another keyframe, and I'm gonna change this back to timeline just so that I can see my keyframes easily. And we should have, yeah, so that in the beginning is not that crazy like before. I'm gonna try to bake the physics now. We're gonna bake the physics, and so that we can watch the animation in real time. So under bake, bake off the rigid bodies, bake all dynamics. It's gonna be pretty fast, it's not that crazy, by the way. If you have a longer timeline, you have to check that the length here is the same of your timeline. Otherwise, the physics will stop at some point. And either way, yeah, nothing more than that. Even if it's not perfect, this specific example, this is the workflow. It's up to you to tweak all the settings. Let's see how it looks. And here we go. An octopus is moving on its own. It's pretty crazy. You can also animate the turbulence in order to stop at some point if you want. But look at that. It's looking all around the map. It's rotating a little bit on left and right, looking for its own path. Alright, that's it for this tutorial. This is how I would animate a creature in Blender. Consider joining my Patreon for learning with me, and I see you in the next video. Cheers!